find the distance of 2, 1 from the line 2x plus y plus 5 equals to 0 along the line y equals to x. So we'll move along this line from 2, 1 towards 2x plus y plus 5 equals to 0 and find the distance. So how do we do this? Pause the video, think about it. Okay, let's do this together. Let's plot things. This is our point 2, 1. This is our line 2x plus y plus 5 equals to 0. And this is our line y equals to x. This yellow line. All right. So we're not asked to find the perpendicular distance. We're not asked this distance. We're asked the distance along this line y equals to x. This means we'll move along this line parallel to this line. And this is the distance that we need to figure out. So how do we do this? So perpendicular distance is not something that we want. So we can't use the formula for perpendicular distance. We want the distance along the line y equals to x. What can be our strategy? So here's what we can do. Perpendicular distance is not what we want. We want to move along y equals to x. Along means parallel, which means we need a line parallel to y equals to x. So if we move along this line, we need to find a line parallel to this that's passing through 2, 1. This is the line that we want. If we know this line, if we know the equation of this line, we can find the point of intersection. And once we have the point of intersection, we can use distance formula to find the length. Can we find the equation of this line? Pause the video, try this on your own. Okay, so the line y equals to x has the slope 1. And if we want a parallel line, we need the slope same as y equals to x. So the slope of line that we want is actually 1. Now using slope point form, because we already have a point, using slope point form, the equation of this line that we're moving along, that's equal to y minus 1 equals to slope is 1. So 1 times x minus 2. The point is 2, 1. If we rearrange this, we have y minus 1 equals to x minus 2 or y equals to x minus 1. So now we have the equation of the line that we're moving along. Y equals to x minus 1. Now we need the point of intersection. Let's do that. Let's find the point of intersection of y equals to x minus 1 and this white line 2x plus y plus 5 equals to 0. So this line and this line. Let's use substitution. Y equals to x minus 1. Let's put that here. 2x plus x minus 1 plus 5 equals to 0. This is 3x plus 4 equals to 0 or x equals to minus 4 by 3. Which means the x coordinate is minus 4 by 3. Plugging x equals to minus 4 by 3 here. Subtracting 1 from this. Y equals to minus 7 by 3. So now we have the point of intersection as well. This point is minus 4 by 3 comma minus 7 by 3. So we're moving along this line y equals to x and then we intersect this line at this point. So this is the length that we want. We can use distance formula for this. So that's y2 minus y1 square plus x2 minus x1 square whole of this square root. So square root of minus 4 by 3 minus 2 whole square, the difference of x coordinates, and then minus 7 by 3 minus 1 square, the difference of y coordinates. This is minus 4 minus 6, that's minus 10 in the numerator. Squaring that gives 100. So 100 by 9 plus minus 7 minus 3, that's again minus 10. So that's also 100 by 9. So this is 100 by 9 plus 100 by 9, that's 200 by 9. Taking the square root will give us 10 by 3 root 2. This is the distance between this point and this point, which means this is the distance of this point from this line measured parallel to or measured along this line. Let's solve one more. Find the direction in which a straight line must be drawn through the point minus 1, 2, so that the point of intersection with this line x plus y equals to 4 is at a distance of 3 units from this point. So let's break down what the question is saying. Here's the image. We need to find the direction in which a straight line must be drawn through this point minus 1, 2. Where is minus 1, 2? Okay. This is minus 1, 2. So we need a line through this so that the point of intersection with this line x plus y equals to 4, this white line, this is x plus y equals to 4. The x-intercept is 4 and the y-intercept is 4. So we need a point of intersection which is at a distance of 3 units from this point minus 1, 2. Which means this line x plus y equals to 4, wherever it hits, this length is 3 units. So the distance between these 2 points is 3 units. This is the condition. So we need to figure out the direction of this line. How do we do this? Pause the video, think about it. Okay, so let's focus on this point. We know a lot about this point. Let's label this point h comma k. Let's assume that this point is h comma k. What are the things that we know about this point? The first thing is that this point lies on this line x plus y equals to 4. So this gives us one equation in h and k. This point lies on this line. What else do we know? We know that this point is 3 units from this point minus 1 comma 2. So the distance between h comma k and minus 1 comma 2 is 3 units. This should give us the second equation in h and k. Using both of these, we can figure out h and k. And once we have this point, we can figure out the slope of this line. So let's do that. H comma k lies on x plus y equals to 4. This means h plus k equals to 4. And now let's use the distance formula. The distance between h comma k and minus 1 comma 2 is given by this. H minus minus 1 square plus k minus 2 square root. This is equal to 3. Now let's solve both of them. Let's simplify the square root equation. We have h plus 1 square plus k minus 2 square equals to 3 square. That's 9. We have squared both the sides. Now let's replace k minus 2. K is 4 minus h. So this is 4 minus h minus 2 square. Now let's open the squares. We have h plus 1 square plus this one is h minus 2 or 2 minus h. Both of them work. 2 minus h square. Opening the squares gives us h square plus 1 plus 2h plus 4 plus h square minus 4h equals to 9. So this is 2h square, 2h and minus 4h, that's minus 2h. And then 4 plus 1 is 5 minus 9 is minus 4. So the equation is 2h square minus 2h minus 4 equal to 0. Now this is a quadratic. This means we'll have two values of h. We'll see what that means once we have the values of h. So 2h square minus 2h minus 4, we can cancel out 2. This is h square minus h minus 2 equal to 0. Now let's split the middle term. H square plus h minus 2h minus 2. So h common, h plus 1 minus 2 common, h plus 1 equals to 0. This is h minus 2 times h plus 1 equals to 0. So the two values of h are minus 1 and 2. And if we plug them back, we'll get k as well. In this case, k will be minus 1 goes this side. This becomes 5. And then 2 goes to the other side. 4 minus 2 is 2. So the points are minus 1 comma 5 and 2 comma 2. Let's plot these points. So this is minus 1 comma 5 and then 2 comma 2, which means we move to the right. So this is 2 comma 2. Let's figure out the distance. Let's see if these 2 points are really 3 units away from this. So minus 1 comma 2, if we go 3 steps up, we'll reach minus 1 comma 5. So this length is definitely 3 units. This length is also 3 units because minus 1 plus 3 is 2. So here we're moving vertically 3 units up, and here we're moving horizontally 3 units right. Both of these points are 3 units away, which means if we want to find the direction in which this line must be drawn, we can say that the direction is either parallel to the x-axis or parallel to the y-axis. Any of these will work. Both of these are valid solutions. Both of these points lie on this line and they are 3 units away from this point minus 1 comma 2.